welcome everyone. And I think if you're attending this talk, probably it's because you've already sort of thought about things like building out vertical AI. And if you have, then you generally know that what ends up happening is that these AI demos work really well, but as you get into production and start focusing on the last mile of delivery to an actual customer, that's when things fall apart, right? And generally it's because of a lack of context when you're building these workflows. And really it's because understanding what good is very hard, right? It's not going to be just a pass fail for many of these issues. It's going to be whether or not our domain experts feel like this is good enough to be shipped to production. And so I'm really excited to invite my friend, a guest, Chris Lovejoy. Previously, you were like an MD from Cambridge. Now you're working as the head of clinical AI at a company called Anterior, which works on LLM native clinician-led um, AI. And mostly you've been, building out these agents to put domain experts to work, put them into the loop, and figure out what we can actually build. And so, in the next 30 minutes, you'll learn a little bit more about how you should be thinking about how to leverage your domain experts. I think your surprising take on whether or not you think prompting versus fine-tuning is the way to go. And ultimately, how do you build trust with the customers of these specialized tools? And so with that, any other questions we can post on the Slido. And yeah, Chris, the floor is yours.
Appreciate it, Jason. Thanks for the intro. So as Jason mentioned, hi everybody, I'm Chris, and I'm going to be sharing some lessons about building AI agents in vertical industries. And specifically, I'm going to talk about a few things. So firstly, a bit about how you can use domain experts to really supercharge AI development, and why I think that building a custom UI is one of the highest leverage things you can do to support them in this. I'm going to share why I think that prompting beats fine-tuning for verticalized agents in the vast majority of cases, but also why you need to go beyond just like prompt engineering, and what are some kind of more advanced prompting techniques that you should absolutely consider. And then finally, a bit about how to get and maintain customer trust through things like intelligent performance monitoring and building a secure LLM native architecture. And then depending on time, I have a kind of a little bonus lesson I can share, but if not, we'll go into Q&As. So we'll see how we do. And then a brief background about me and where these lessons are coming from. So as Jason mentioned, I spent 8 years training and then working as a doctor, which was really where I saw how impactful AI had the potential to be if implemented correctly. And I then went back to college to study machine learning and learn things from first principles. But then when I tried to apply those principles in the real world, I realized that actually many of the principles were either outdated or were really challenging to apply in verticals. And I think this has become increasingly true kind of post ChatGPT in the LLM world. And so I found I had to keep on reinventing the playbook. So I did this first at Seracare, where I built out the AI function. And Seracare was a tech-enabled home care company that recently hit 500 million ARR. And then again at various other companies, I kind of felt like I was reinventing the playbook there as well. Companies I worked at, consulted for, including my own companies. All the way up until today at Anterior, which is very much an LLM native company where we're using LLMs for healthcare admin. I think also one experience I've had is that while healthcare was very much the first vertical that I worked in, since then I've worked across multiple different verticals, including education, recruiting, and retail. And I think a lot of the principles, or probably the majority of the principles, apply across all these verticals. Explicitly, I think the content of this talk, I'm talking to those principles that are generalizable. But before I dive into those lessons, I just want to take a quick step back and ask the question, why is it so hard to successfully apply LLMs to specialized industries? So I think there's a few reasons. Two that come to mind are, firstly, this last mile problem. And the last mile problem is the challenge of taking powerful models and getting them to work well in the specific context of a certain customer and a certain industry. And really what I've seen is that the challenge is no longer in the quality of the reasoning. Maybe 2-3 years ago, these models would often fail in their kind of reasoning in a clinical context or in a legal context or elsewhere. I think that's no longer true. I think now the errors that I see are around the model not having the context on specifically how a workflow is performed in that industry. And I think another component that's also making it difficult to apply LLMs in vertical industries is it's harder to define what exactly is good and what is correct. And you really need a domain expert here to basically translate that. And so not just anybody can come and kind of build and evaluate these applications in these industries. There's like extra steps that you need to take. And I'll talk about what I think that should look like. Okay, so on this first point of how can domain experts supercharge AI developments? So there's this maxim that many of you will have heard of that, one of the most important things when building LLM products is to look at your data. But what if your data looks something like this? You have your AI generating output. This is a legal example, and I'm not a lawyer. I wouldn't know whether this is right or wrong, and in what way it might be wrong. So you therefore can't just look at your data yourself. It's not often as simple as that. What you need to do is empower domain experts to actually look at and then translate that data into something actionable. And I think what that can look like is something like the following. So let's say you have your production application, it's live, it's generating some kind of AI outputs. Um, I propose that you want to then use domain expert reviews to take those outputs and make a number of kind of useful inferences from that. And so four of the top things I think you should be looking to get are you want to get performance metrics. So how well is your AI doing? Like how accurate is it if it's making some kind of decision, or what kind of characteristics and traits is it kind of performing at? What sort of scores are it getting? And then where it's not performing well, what are the specific failure modes that you've noticed in your AI as well? And then also suggested improvements. So how might you actually improve your system? What are different things that maybe you could even automatically put into your agent and into the context that might improve things? And then also input and output pairs. And I'll touch a little bit later on how that can be useful and what that might look like. But if you're able to do domain expert reviews and get these kind of outputs, there's a number of helpful things that you can then concretely do with that. The first of those is it enables you to quite nicely prioritize work. You're using production data, so this is very representative of the kind of data you're going to be getting going forward. And you can plot graphs like this. So for any particular error metric, any particular way in which, like the kind of metric that you most care about and your customer most cares about, you can see what sort of failure modes are most contributing to that, and therefore where do you want to focus your efforts to improve them. What you can also then do is get these ready-made failure mode data sets because you've reviewed from production, you've said when it's wrong and in what way. You now have these example inputs that your AI received that were wrong, and you can group them by failure mode, and then you can give that to an engineer, and they can make changes and they can see what's the impact on the performance. So these are grouped by particular failure modes, and if you initially these all came from production, you probably have 0% accuracy, but as you make changes, you'll be able to retest it and see what the impact is. And that lets you do things like this, where you're making changes to your pipeline, and maybe between different increments along the x-axis here, you're improving certain failure modes and deliberately like focusing on how you could improve those. And then you'll see jumps in that and performance over time. And you kind of get this gradual trend over time. And then you can obviously also then check that you're not regressing on any other failure modes once you're making those changes as well. And the overall process that this enables, and why I think this is really powerful for vertical AI applications, is that this is kind of a continuous loop that you can perform that really embeds context about a specific way that a customer performs and a specific way in which the AI is wrong for that particular customer today, and lead this full iteration loop to then improve it. So it looks something like this. So you have your production application, you're getting your AI outputs, which gives you the performance and the categorization of failure modes. You can then give that to a PM, and in my experience, it often makes sense for this to be a domain expert PM. They can then specify a failure mode that they want to be fixed based on the priorities and how much it's impacting your top line metric. They can give it to this engineer. This engineer can test against that ready-made failure mode data set. They can keep on making changes and see what sort of impact it has. And then once they're happy that they've come up with some changes that really improve it, they can again give it back to the PM. The PM has the full context on all the different work that's going on and the kind of downstream impacts this might have, and can then make decisions about going live. And you can do this whole process in a very short period of time if you have all these kind of like fundamentals in place. And I've talked more about this in more detail here at this link. So feel free to check out the full video. But this is kind of like I think a very powerful process that can really enable you to solve this last mile problem. But that's kind of the downstream. That's once you're getting these different pieces of information that you want, your performance metrics, your failure modes. The next question then is, how do you actually perform the reviews that get this kind of information? And you can often start in a relatively low-tech way. People often start with Google Sheets, or maybe you just look at the raw traces in LangFuse. There are also various like eval vendors that will give you these dashboards. But my take here is that you very quickly run into limitations with a lot of these approaches. For example, it's not easy to integrate the downstream data that you're generating from these reviews into your production application. And you can also run into limits of what you can present. So obviously in a Google Sheet, you have a 2D view, and it's very hard to like surface the kind of context that you might want to. Whereas I think that building a custom review dashboard is really the way to go because it solves these problems. It gives you maximum freedom over how you can present that, and it's very easy to then embed that data downstream into your system. And so this is an example custom UI that we built at Anterior. And here on the right-hand side, you have your medical record, and then you have this other tab for your medical guidelines. You can kind of scroll up and down. So all of the context that you might need is available. And on the left-hand side is the specific question that the AI is answering right now. So you have the context where it is, and then you have the question, you have the AI's answer, and then you have this box at the bottom which enables you to then annotate that. And is this annotation box that enables you to get these four pieces of interest. So you can say whether it's correct or incorrect, and by doing that, you're getting performance metrics. You're seeing, how often are you correct, and you can chop and change that based on different axes of interest. You're getting the failure modes because there's this button here for tagging the failure mode. You click on that, and it opens up the failure mode taxonomy that you can then select from. And for suggested improvements, the way that we do that is you have this domain knowledge button. You can click on that, and you can then insert some kind of domain knowledge that you think if the LLM had that domain knowledge, it would have been correct on this particular question. And for the input-output pairs, you can also then have this drop-down, which enables you to specify what is a correct output. So you have all the input information here, the context, and then you get a correct output. And that can be helpful in a number of ways. And I think the general principles when building a custom UI, my kind of proposition is that there are three things you want to be optimizing for. And the first of those is high quality reviews. I think if given the choice, you want a low volume of high quality reviews rather than high volume of low quality. And this is because you really want to be able to trust the metrics that you're generating. And you might use this data downstream, maybe for fine tuning models, or maybe for actually concretely putting it into your production application. And so, you really want to be able to trust that. But equally, you also don't want your reviewers to spend ages doing every review and get reviewer fatigue. So you also want to minimize the time taken. And then the third point of generating actionable data, that's basically generating these kind of outputs that I'm talking about. And I think there's three high-level principles that I always try and keep in mind when building out custom UIs that I think meet these objectives. So the first is optimizing for clearly surfacing all the required context. So in the example that I showed, on the right-hand side, we had the kind of wider context, and everything that the user might need is there, and they can like scroll through it, but we're abstracting some of it away, so it's not like overbearing on the screen. And on the left-hand side, you have the more specific context for the user to drill into, which then is kind of also helpful to have that separation kind of cognitively. And then I think, you want to have all the information available, but then you don't want to overburden. So you might use, like I showed, like tabs, sidebars, nesting, different sort of techniques to abstract things away. And then for the second principle of optimizing the review flow sequence, my take here is that you want to form an opinion on what the ideal review flow is, and then kind of bake that into your custom UI. And that might be through visual cues. It might be actually by enforcing that the reviewer does certain things step by step. And then you want to invest effort in really minimizing the friction of performing that review. So making sure the information is available in the right place so that you're preventing scrolling, clicking, kind of too much manual work on behalf of the reviewer. And the process that I've seen helpful for this is doing a lot of shadowing of domain experts doing these reviews and understand, what are the natural variation in flows, because typically I've seen that actually these reviewers often have their own flows, and then forming some sort of opinion on what you think makes the most sense and baking that in. So that's the first point. On my second kind of lesson here is around prompting versus fine tuning. And I think this is obviously a kind of common question, and probably the answer to this is continually evolving over time as well. My take today is that for the majority of cases, for vertical AI applications, better prompting is more important than fine-tuning models, and it's a better way to improve performance. And I think this relates to the fact that in verticals, the typical issues you'll face are around having the right context rather than the reasoning of the model. So with fine-tuning, it's often not necessary because actually out-of-the-box models today are great even at domain-specific reasoning. They have that kind of data in their training data. Um, and also, I think whenever you're doing fine tuning, you're adding a bit of complexity that you're not necessarily adding if you're prompting. Um, so, you might be fine tuning per task, and then you might fine tune across different customers as well. So you're having like lots of different models that you're having to manage, and you need to monitor the performance for all of those models. I think with fine tuning, you're also doing that at a specific point in time using a certain set of data. And actually, the way a workflow is being performed or the way an organization operates can evolve over time. So that performance can naturally deteriorate. Um, and so, yeah, this is why I think prompting is often an optimal solution. I think the arguments for fine tuning outside of performance can still absolutely be there. So things like optimizing for speed, optimizing for reducing costs, and for scalability, all that sort of thing. But I think as a first go-to, my take is that prompting for improving performance is typically the best place to start. But I think on the prompting front, my push would be that I think just actually tweaking the prompts themselves and really over optimizing those can be quite brittle, because it's fiddly. Every time you change a prompt and change some words, you might improve in one area but cause problems in another area. There's also a degree of model dependency. So some prompts might work well for some LLM and then less well for another LLM, but you really want to have the ability to kind of chop and change large language models, to keep on top of progress. And then I think also the static point is true as well. If you're using static prompts, then as I said, the organizations and workflows can continually evolve and change over time, and how they operate. And therefore the kind of prompts themselves can become stale. And so two techniques that I think really are very effective in vertical AI applications are firstly context augmentation. And so this is using a domain expert generated knowledge base and kind of like injecting that into the prompt context. So in the UI I showed before, we had this add domain knowledge button. You have your domain experts who might then add in some information that can then get retrieved at inference time and used by the model. And here, the bottom left, there's an example of this happening in finance, where an example bit of domain knowledge might be that for some specific regional bank, they define a high net worth individual as follows. And this might be really important for when an LM is performing some sort of decision making around high net worth individuals, because actually different banks will have different definitions. And so you really want to give the model that's operating in that specific customer's context understanding of how that customer makes that definition. Um, and yeah, and so these are other finance examples as well. And then I mentioned before input and output pair examples, and this is useful for in-context learning. And what's helpful here is, sometimes with prompts, it can get tricky to, explain things explicitly yourself. And actually, really what you want to do is just show it through examples. And so you can do few shot prompts where you put in, 7, 10, 12, sometimes more examples of input output pairs. And you can do smart things like you can put an input output pair, which was initially wrong, and then put the correction from a domain reviewer. And that's going to help the LLM to not make that mistake in future. And again, this is something that you would want to retrieve in real time, while doing inference. And kind of the next point here that really builds on top of this is that you can actually go beyond just tweaking this kind of context and doing this very dynamically and in an automated way using evaluations. And this is particularly helpful as you start to scale and serve many different customers across different workflows. And what this can look like is you have your domain expert UI, they're generating new domain knowledge on input output pairs, and they kind of live in a domain knowledge base here. You then have these evals you can run against, which could be failure mode data sets, could be other evals that you build. And you can see which of these are useful and in what sort of contexts, and you can use them in real-time retrieval of that knowledge in your actual application pipeline. And the retrieval here, sometimes you can do keyword matching. So, for example, for the ultra high net worth individual one, you might be keyword matching on that text or the acronym and this kind of thing. You can also do semantic similarity. You can weight by recency, which helps with the fact that things trend over time and there might be changes in the precise workflow. And you can do things like optimizing for diversity by picking input output pairs that are most similar to your query, but that are most different to the existing input output pairs. And this, I guess, the main like I think advantage I see here being that you're really baking in what is the most recent relevant information you have on how a particular context, how a particular like workflow is performed, and giving that dynamically to the LM in context. And therefore, you're really doing this real time and kind of as close to the customer as possible. Okay, so third and final lesson, plus or minus the bonus lesson, is about getting and maintaining customer trust through performance monitoring and a secure LM native architecture. So when I think about getting trust from a customer for a verticalized agent, I think of three primary things. The first is getting confidence in the AI's performance. The second is confidence that you're handling data securely and correctly. And then thirdly, that you're aware of these LLM specific attack vectors that are continually evolving and you're taking active efforts to mitigate those. So in terms of the first one, achieving AI confidence by monitoring and reporting performance. I think there's a few things here that I've seen work well in practice. The first of these is doing reviews of production outputs and getting these performance metrics. And you can use a UI like the kind of UIs that I've shown. And then with those metrics, reporting those to customers, whether that's bi-weekly or monthly, but giving them insight. This is particularly obviously relevant in a kind of enterprise context where they want to understand how things are performing. Um, and as things scale, you will then obviously run into this case where you can't review all AI outputs, and it doesn't make sense to, but you'll need to define a sampling strategy such that you're therefore reviewing the highest priority cases. And this can be things based such as uncertainty. This can be looking for outliers. This could be stratified sampling based on certain characteristics. And then you want to also have an internal response protocol such that whenever performance deviates below certain targets or SLAs, you have some way to respond to that. And this is things like defining who has responsibility for the performance and improving it, what kind of techniques you might use, and how do you make sure that when you're closing that loop, you're not introducing any other errors. And with things like regression data sets. And then finally, you can use LLM as judge evaluators to help scale the ability to monitor. I think explicitly I would recommend not starting with this. I think it makes a lot of sense just to start with human initially and really kind of get the ball rolling. And then later you can always introduce as LM as judge. But it can be very helpful once you're starting to run into problems of scale to be able to use this. So I'm just going to talk through a specific case study that I was involved with, where we were using evals for a mission critical healthcare application. And I've shared this in more detail earlier this year in New York at the AI Engineer Summit. So you can see the recording of that if interested. But the kind of problem setting was that we had an AI agent that was answering medical questions like this. So does the patient have a brain MRI suspicious for multiple sclerosis and giving some output answers. But because the agent was processing a large volume of cases, there was no way that the user could actually review all of those cases. And they could, review around 5%. And so if you have all of your AI outputs and the 5% here represented by the red, all the ones that you're able to review because you have capacity, then you have these two questions. For the cases to review, you have to ask, okay, which cases should I review? And then for all of the ones which you don't have capacity to review, the question is, how did you do on those cases? And we use an LLM as judge to solve this. So you have your kind of input, it goes through the actual pipeline itself, generates some kind of output. That would then be passed to an LLM as judge. And what the LLM as judge would do is it would use a scoring system. It was reference free, so it didn't know what the actual answer was. And this was happening real time. It would then generate some kind of confidence in that original answer. And in this case, we're answering yes, no questions. And so therefore you can use that confidence and set a threshold to determine what the predicted correct output is. So if, for example, your initial pipeline said that yes, the answer is correct, and your confidence was low, then you might flip that, and actually the LMS judge thinks the answer is no. This can be helpful in a couple of ways. So firstly, with the predicted outputs, you can therefore get these performance metrics like I talked about, which you can then communicate with customers and use internally to understand how you're doing and to drive efforts. And you can also then get alignment because for this subset of cases where you're doing both human reviews and LMS judge reviews, you can compare how much do they align with each other. And that gives you insight into the performance of the LMS judge. And then the second part of this is that the confidence grading you get, you can actually directly use that to prioritize reviews. And so we built a system that's used these confidence grading from the LMS judge. It used other factors such as procedure cost and risk of bias and error rate on that guideline. And then of all of the cases that you have, you can rank them and you can prioritize which ones you want to do reviews on. And this made this really positive feedback loop where the LMS judge was surfacing cases to review and prioritizing those. We then had human reviews were then actually reviewing those cases and determining the accuracy of the reference free eval, the LMS judge, So we would then make changes and improve the reference-free eval. And we kind of kept on doing that, leading to these improvements. And then once it gets to a certain point and the accuracy of the LLM judge system is strong enough, you can then actually put it in the pipeline itself. So now what is live in production is that the input comes in, you get the LLM pipeline being activated and generates some kind of output. It then goes to the reference-free eval, the LLM as judge. And if it's confident, it will then go ahead and return that to the customer as it would have before. But if it's not confident, then it can go and take another action, which might be sending it to another LLM or doing some initial processing, or maybe even escalating for a human review before returning it to the customer. And so that's about confidence in the performance of the AI. The other points I want to touch on is around kind of data handling and LLM specific attack vectors. I think on data handling, there are many different things to think about. Three kind of top considerations that come to mind. The first is that I think it makes sense to map out your data usage strategy early on. And this is for things like how you want to use customer data for performance monitoring, how you might want to use it for fine tuning. And I've seen this be particularly important in enterprise. And the reason I say early is because it's helpful to be able to discuss these things in the contracting phase. You can avoid this scenario where later on things are a bit ambiguous about how you can actually use that data, and you're therefore not sure necessarily what you actually can do with it. And I think it's helpful to come to these contract negotiations and discussions with an opinion on how you want to use the data. I think one reason that's important is because a lot of customers that are kind of buying these products are often still operating in kind of old traditional machine learning paradigms. So they're actually not even necessarily sure what they should be asking for and what like sensible data usage strategy looks like. But I think then come with that opinion and then have a collaborative discussion, because actually it might depend on the specific customer, what they're interested in. In some cases, some might really want to fine tune a model and get some sort of performance gains. Others might explicitly not want to fine tune a model and therefore don't want you to be able to do that. And an opinion here, typical things you might consider is agreements to hold on to data to do QA and performance monitoring for like 3 months or 6 months. Maybe you want the option to do fine-tuning experiments, and then for those experiments, you'd only train on that customer's data, and that model would only ever be available for that customer. And these kind of exclusivity things, I think, are often important. But in general, yeah, it's useful. It's useful to just like have that strategy early on and kind of iterate on that with customers. Second point here is, it's worth being ready to offer customers isolated single tenant environments with their own database instance, perhaps their own model instance. Just having that in mind, because some customers will explicitly want that. And then I think a final point on data I want to call out is considering investing in synthetic data generation, whether you want to use that data for performance monitoring or for fine tuning. I think depending on the complexity of the data that you work with, it can often be quite hard to make synthetic data that is an accurate representation of production data, but that doesn't necessarily mean that it can't be helpful. And one way that I've seen really the synthetic data has been helpful is that you can be serving different customers, doing this process I've described and identifying certain failure modes, and then you can generate your own synthetic data based on those failure modes. And there it actually matters less whether that data maps to the same input data distribution. What's more important is that it's able to elicit the failure modes, because then you can create these failure mode data sets and you don't have the same restrictions with that data compared to, for example, you have a customer data, maybe you have an agreement, you only hold on to it for 3 months. If you build your own synthetic data, but it still elicits those failure modes, then that's useful kind of IP that you have as a company and that you can use indefinitely. So those kinds of things I think are really helpful. And then just finally to touch on a couple of LM-specific security considerations. You may well have heard of things like prompt injections, where a malicious actor can get instructions into the inputs that make your LM act in ways that you don't want it to. And there's best practices here, like doing input filtering, and I've seen some kind of elegant solutions around wrapping the initial query in another LLM that basically is just a classifier to see whether this might be a prompt injection. Things like validating the outputs, requiring human approval for high-risk actions. Then obviously preventing sensitive information disclosure. Often in vertical industries, you're working with sensitive industry data, and you might want to do things like sanitizing the data, where you remove certain information, such as PII, before you send it off to an LLM or before you do any training. And you want to avoid things like data and model poisoning, which is where somebody kind of deliberately puts adversarial examples into a training set for things like backdoor attacks, for maybe just even reducing the accuracy of your LLM. And And best practices there are things like track your data origins, inspect your data before doing training, use data version control, this sort of thing. I think the kind of high level point here is this space is very much like evolving, and it's worth just exerting some effort to keep on top of it. This is a report here from OWASP that I think is a pretty decent summary of what some of the top risks are and what some of the best practices are. But you just want to be able to kind of keep on top of that and have an opinion, bake that into your products. Okay, so I have this bonus lesson which I think is it's in a couple slides, maybe like 5 minutes. Jason, what do you think? Should we dive into
I
Q&A
would
or?
personally love to see this.
Okay, cool. All right, in which case let's go through this one and then we'll
Yeah,
answer
I
questions.
think the chat agrees as well.
Cool, awesome. All right. So, which domain experts should you hire and how should you use them? So my opinion here really is I think there's a lot to be said for hiring a principal domain expert. And this is somebody who has ultimate responsibility for the performance of your AI and defining what's good, defining what's correct in certain circumstances. And I think the argument for this is one is organizational. Having them as a DRI, as a directly responsible individual, helps you to move faster. You avoid consensus by committee. Sometimes you'll have uncertainty over whether some kind of nuanced output is good or not, or is correct or not. Having somebody who can make the final decision on that is really helpful and kind of like unblocks you to move faster. I think because this person can be very important, it makes sense to hire them as early as possible, bake their kind of thinking into your product, and really give them ownership so that they hang around. And I think the reason this person is important is that they can really build perhaps the best intuition in your whole company for how your AI system performs and how it can be improved. Because they'll spend a lot of time looking at the data, looking at these interactions. They have the domain expertise, so they can therefore interpret it. Um, and then they can also play this very important role of actually going beyond just looking at the data itself and designing and creating this high level system around that. A lot of the things I've been talking about in this talk, like I think it makes sense for them to really be steering that. And so, um, explicitly a few other things that they can help you with. As you scale and you're generating more AI outputs, you'll probably want to hire a team of reviewers, and they can help with that. You'll also then want to define your sampling strategy, so you're picking the most relevant subset of cases to review. You'll want to analyze review data. You'll want to monitor performance of different reviewers. So are all your reviewers performing above a certain standard? Do they agree with each other? Things like steering product development, prioritizing engineering work, talking to customers can be helpful, explaining things and also understanding what the customers care about. And then obviously the things I touched on, like improving the actual AI performance itself, tweaking prompts, adding domain knowledge, that sort of thing. And so when it comes to actually hiring this principal domain expert, my proposition, my take here really is that you want somebody who has as many of these kind of experiences on the right hand side as well as their domain expertise. So you kind of want them to meet a critical domain expertise threshold, and we can talk, in the Q&A a bit more about what that looks like. But it's very helpful if they have management leadership experience because then they can manage this team of reviewers that you hire at, and they can hire those reviewers from their industry connections. And likewise, if they have statistical experience, they can define your sampling strategy, they can review the data, they can steer product development, if they have product skills, this kind of thing. And as an example at Anterior, and if you excuse the self-reference here, I played this role at Anterior. So I was initially reviewing medical outputs, like kind of medical AI outputs, because of my medical background. And then as things grew, I had my network in healthcare. I could quickly find reviewers. I have a background in data science, so I defined our sampling strategy, that sort of thing. And then I'm also a software engineer, so I kind of could get hands-on with like the AI implementations and trying to steer things on that side. And I think in general, having one person who really kind of steers and owns on this side of things enables you as an organization to move much more quickly. Cool. So that's everything I wanted to cover before we go into Q&As. Just quick call outs. So if you're a business that's working in a vertical industry, I'd love to share learnings and talk about some of the problems you're working on. And I have some limited capacity to chat, but if you scan this QR code, if you want to book some time with me. I also have a personal mailing list. The link is here on the left-hand side, where I share, my learnings as I'm building out different vertical AI applications. And I am sharing a free ebook on building AI in vertical industries towards the end of October. So if you want an email notification when I release that, feel free to sign up here. But yes, thank you for your attention, and yeah, we'll now dive into questions.
That was great. Thank you so much. I feel like, especially the talks on domain experts, having a DRI makes a lot of sense, but I find that in most cases, it is just a case that, oh, by the way, Jason, we have a couple of folks like on one of our like customers that will look at some things for us.
Yeah.
And so I think that DRI is pretty critical. Um, yeah, so if you don't mind, let's jump into some questions and see what how much we can get through. All right. The first question is around like, the transition from maybe what we would consider like a traditional RAG system where we do this like one-shot search and then we build out the context, compared to like a deeper like agentic RAG chatbot. Like, how have you thought about these kinds of differences in building the applications you're seeing these days?
Um, yeah, it's a good question. I mean, I think it's obviously important to have the kind of different context available for these agentic systems to be able to kind of call on them and setting it up such that explicitly they're able to um, kind of access the context that they need for the relevant decisions that they're making. So some part of it from an agentic context is, if a certain task is being performed, uh, what are the types of context that that might need, and how do you make sure that they can like surface those available, and the methods that you might use for retrieval in one context might be different for in another context because it really kind of depends on the relative priorities for whatever particular task you're performing at that time.
Yeah, I would also call out another fact, which is a fact that Colin, who gave another talk, talked about, which is this idea that the agents are much more persistent in the way that it does search. And so one of the benefits of having an agentic system is you're really trading off a bunch of latency during inference time, but the agentic system will try again, right? It might do 5 tool calls, read some information, do 5 more tool calls. And so if you think that the information is very hard to find, right, where maybe your embedding search or your full text search is only like 60%, 70% accurate, um, having an agent in the loop really allows you to improve the end-to-end recall of the system. Um, another question someone had was around data extraction and data triage. Um, it says, what do you think? Do you think we should be separating data extraction tasks from data triage tasks in the ingestion phase?
Um, and just help me understand that one. So, as in uh, data ingestion versus data triage.
Yeah, maybe if the person asking the question could maybe just leave another comment in the chat, but I can imagine some maybe this interpreting this question as a bunch of data coming in. Maybe some of them are health records, some of them are, schedule, some of them are, scans of other data. I guess there is sort of one stage, which is understanding what the data is about, and the second stage of extracting the data out, uh, maybe in some
Yeah,
kind of structured form or anything like that.
yeah, no, that's a great call out, and I think my experience, I've seen it be very powerful, understanding, like building an understanding of the context of that data that's come in. So whether it's like sometimes you have medical records, they might be a couple of hundred pages long, and they might have like different encounters and different types of information. I've seen performance like be very significantly improved by actually kind of getting the semantic context of, okay, this was like an encounter of a certain type, and this was one was another type, getting some sort of like summarization of that. And then when it comes to retrieving context, the agent or the system that's trying to find that relevant information has an understanding of that information. Um, I think that's particularly important, yes, when you're working with large volumes of data and when the data is, um, yeah, kind of like different in nature. I think being able to separate that out to support retrieval is I've seen it be very effective. Yeah.
Yeah, I would also call out in the slide that you had earlier on these like failure modes. Generally, what will happen is as you identify these failure modes, you can go backwards and figure, okay, well, if these are the failure modes, then maybe we need to do more investment in certain kinds of data categories. The example I always give was we first had just search over PDFs, and then we found that actually what people care about is filtering for contracts that were signed or not signed. And so now we classify, is it a contract? If it is a contract, we extract was signed, right?
Yeah.
None of this is difficult, but a lot of it is around looking at data and understanding what the use cases are.
Yeah,
Um,
100%.
yeah, another question here around what are your thoughts on handling missing data during processing? If some data points are missing, how do you address this issue? This is a very
Yeah,
general question, but
yeah. I mean, I think uh one part of this is like, can you identify a way to identify if information is missing? And so you can explicitly have some sort of like output from the system being like a decision saying, hey, information is missing, and maybe like requesting more information. Um, I guess the following question is like, okay, well, what does that system look like? Like, how do you actually get it to know when information is missing? And that probably depends a bit on like the specific use case. Like, is there certain information that should be available? Like, there's certain context that should be included somewhere, and therefore you can have like separate classifiers to pick up was that contained. Um, but yeah, I mean, sometimes it's tricky, right? Because you don't necessarily know what you're missing. Um, I think one other component here can be more generally just having like some sort of uncertainty threshold, for example, for returning a response. So maybe if your system or your agent has reviewed the relevant like evidence and context, and it's just not sure it can make a decision, it can escalate that under like a level of uncertainty. And therefore it's not explicitly saying it's have missing information, but it's like I don't have enough information to be confident. And so that's like supporting that scenario.
That makes sense. And then here, when you are finding these failure modes, how do you evaluate and decide where to devote effort into, the various techniques to improve performance?
Yeah, I mean, I think a lot of this is a bit of a judgment call. So one thing I've found helpful is trying to group failure modes, maybe based on common ways that they could be fixed. And actually, I think I have a slide in the appendix that's relevant to this. Yeah, I think this one. So for this project with like a medical necessity review, we found the failure modes were broadly, in clinical reasoning, in interpreting the rules that the AI needed to follow, and actually in the medical record. And let's say you see that a bunch of failure modes are in medical record extraction, you can then sort of like tackle those maybe at the same time because there might be that there's some sort of pipeline you want to build that uses like OCR with large vision models and it supports both table extraction and photo extraction, and checkbox extraction, and you can kind of solve multiple failure modes at the same time. But I think that there's not really a hard and fast rule I can think of for prioritizing these. I guess it's a bit of an art. You obviously have the metrics such as like how are the failure modes impacting the metrics that you really care about. You can look at that data, but then the interplay is a little bit more nuanced, and I think that's where kind of like the PM or like maybe this domain expert PM plays this role of like integrating their understanding of the wider system, the types of failure modes, the data, but also their intuition for maybe some failure modes having common causes, that sort of thing, to help steer things there.
That makes sense. Um, I guess another question on this agentic RAG part was someone had asked, with multiple tool calls and agentic RAG, how do you think about balancing the risk of degrading the user experience with latency versus the need for more accurate multi-step reasoning? And I guess here, for most of your use cases, how latency sensitive are these things? Are you answering questions while the patient's there, or is it like running in the background? And
Yeah, no, and I think the critical thing here is basically like how is it being used? Because I've seen systems where it runs overnight, and then the purpose is like it runs at nighttime and it comes back, and then the domain expert, like a nurse or a doctor, will come in and they'll have that ready for them, and then they kind of like process it. And their latency is like not really an issue, and actually you just want to prioritize for accuracy. But then equally, in other cases, it might be while a patient is in the doctor's room, you actually really want to prioritize quick request responses, and then it's more of like an explicitly, the time is a trade-off. Um, and so, like, I guess the heuristic, this obviously is a case by case basis. If you can get insight into your system and what that trade-off looks like, so if you run a quicker version of your product, what's the accuracy, and then a slower version, what's the accuracy? Having that gives you the insight that you can lean on to make these sorts of decisions. But I think the primary driver is like, what's the specific, context of your application? Like, how's it being used, and how time sensitive is that?
yeah, I think a lot of it really is around not about like, is there latency or is there an issue or an accuracy, but just, you have some budget and you just have to allocate it in some effective way. Right?
Yeah,
Sometimes
yeah,
doubling the latency isn't worth a 1% improvement in performance, but in the medical context, I can imagine a lot of situations where that actually
yeah,
is the case. Um,
yeah.
Down the line of actually doing more like information retrieval, I think this is a question that often people ask, which is how do you manage information getting old or stale, right? Does your domain experts like review the knowledge base itself, and how do you think about that workflow?
Yeah, great question. Um, I mean, one kind of quick thing you can do is you can have like a weighted preference to more recent examples. So let's say you have your domain knowledge base, you know when all that domain knowledge was created. You can retrieve like upweight by the relative recency of that. And you can even like introduce cutoffs. Like let's say it's used in some particular workflow where guidelines are changing really quickly, or there's like I know it's in cancer space and there's like new research coming out all the time. You might want to like actively do hard cutoffs over a certain period of time. But yeah, I kind of think recency is one component of it. There was maybe something else I was going to say, but I can't remember what it was. Um, yeah, maybe it'll come back to me.
Yeah. And one thing to add here too is there's a really great talk that Glean had done a couple months ago where they're talking about this idea of authority, right? And it's actually the case that it's not all data. It's not always the case that recency is the highest quality data. And the example they gave was like the Wi-Fi password, like in Jira. Like that document is 7 years old, but actually it is the document is like the most referenced. I can imagine situations where, like the health records or something like that. That might be something that is like very old but still very valuable. But it really
Yeah.
highlights the case that information retrieval, authority, ranking, these are all very important problems when thinking about these RAG systems.
Yeah. Actually, no, I remember the point I was going to make was also, yeah, I think sometimes getting like extracting explicit metadata about the data that you're getting. So, for example, um, you might get very unstructured medical records that you might receive that don't really come with any metadata, but actually somewhere in the record it says like what date did this encounter come from. If you can extract that and keep that representation, then that can be helpful. And again, yeah, older things can absolutely be helpful. Like it might be an encounter from 10 years ago that's super irrelevant. Um, and yeah, or it might not be.
Totally. I guess a question that I'm personally interested in, which is around citations. Like, how do you guys think about citations and references when doing things like answer generation? Like, do you have any specific workflows around that, or do you just use like the Anthropic citation API?
Yeah, I think we've used different approaches. We've used like before the Anthropic, we were either kind of doing it ourselves and like prompting LLMs in certain ways to get it to give those citations. I think yeah, which one is we've moved more towards actually just like using Anthropic and their approach because I think that that works quite nicely. I think some techniques we've used in the past that have worked well is explicitly like kind of chunking things up, doing some like kind of semantic similarity based chunking, and then just when you're prompting the model, getting it to call out these like UID set chunks that it like used to make a decision. And so the kind of procedure would be say what's the relevant evidence, like return the UIDs for these particular chunks, then like reason around that, and then make the final decision. And so it's kind of sequentially going through those, and you therefore get the citations uh, from that as well.
Makes sense. All right. While I scan some of these remaining questions, one question that I always like to ask our guests is, what is a question you feel like folks are not thinking about and not asking themselves when building out
Hmm.
these systems?
Yeah, it's a great question. I think it probably would be maybe this like central point I mentioned a few times of what does your system look like for incorporating domain expertise? I think there's a bit of a bias towards looking at the kind of latest, fanciest, most sophisticated models and how you can use them and maybe how they're like incrementally better on some important benchmarks. And I think that is relevant. But what I often see overlooked is what is the process for like baking in this knowledge and how do you actually like really minimize the friction of that process such that this almost like kind of happens automatically as part of you like running your product um, such that your system is like always improving and adapting.
Yeah, I think that's sort of the main thing that I've noticed when working at least with engineering teams that are less sort of science focused rather than the teams that are very much like mixing with data scientists or have like a academic background. It's around just believing that, okay, once I build this thing once, I can ship it and then I work on like the next set of features. But instead, it really is the case that with these systems, because they're so probabilistic, you're always trying to push the distribution in some correct direction, and building out that flywheel is very important to be able to systematically improve these applications. Um, with that in mind, I think we're basically at time. We give some time for folks to wrap up and then attend the next couple of things they gotta go to. But yeah, Chris, thank you so much again. Make another call out to some of the links that you had shared. If you want to book some time with Chris, there's the QR code that you see on the screen. And if you want to check out your newsletter, it's chrislovejoy.me/email. And yeah, I think I don't know if you can see the chat, but a lot of great feedback a lot of very excited folks. So, Chris, again,
Did it.
thank you very much.
Cheers, guys.
Take care.